Okay, I'm going to talk you through the notes for partial fractions. So if you've got the CA notes up at the same time as mine, that should be helpful. It's partial fractions, and it's got part A, fractions of linear factors in the denominator. So just to remind you on how you add fractions, if you had a third, add a half, you'd make the bottoms both 6. You would times this one by 2 and times this one by 3. Then you would add the tops. The next stage up, if you look at these two fractions, you would make the bottoms the same. So both bottoms would become x plus 1, x minus 2. This one needs an extra x minus 2 to put it on top. This one needs an extra x add 1, put it on top. Then you would times out the top and tidy it up. Now, what partial fractions is doing that in reverse. So basically, if you were given this answer here, how would you split them up into two separate fractions? So we're used to going from two separates into one. Now we're doing it in reverse. Now, so if you look here at the first one, if you've got an expression on top, it basically goes to something over the first factor plus something over the second factor. So for example, if we had this wee question here, it will go to something over the first factor plus something over the second factor. What we're going to do now is we're going to multiply everything by both these bottoms. So if I multiply this side by both of these, the bottoms disappear. If I multiply this by both these brackets, I'm left with a 2x minus 3 on top. I'll just take it over to the side just to show you exactly what I'm doing here. So you have x minus 9, x add 1, 2x minus 3 equals a over x add 1 plus b over 2x minus 3. So I am multiplying everything by this bottom line. So the first fraction becomes so. The next fraction, now you wouldn't do this out for everyone, you would never do this out, I'm just doing it to sort of give you a bit of understanding here. 2x minus 3 all over 2x minus 3. Over in the first fraction, they all cancel down, leaving you with x minus 9. On the second fraction, they cancel to leave you with this one. And in the last fraction, these cancel to leave you with this. Now, you've got two methods you can use. You can match the coefficients. Coefficients means number in front of. So if you take out your wee line here, now what I've done is I've multiplied this out. So it's 2ax minus 3a plus bx add b. Now if you look at the coefficients of x, that's the number in front of the x's. I've got a 1 on this side equals, I've got a 2a and I've got a b. That's my first equation. So you do your coefficient of x's. Now do the constants. Constants are the numbers on their own. So on this side I've got a minus 9 on its own. And on this side I've got a minus 3a plus b. So I have got two equations. And just solve them simultaneously. So if you look there, I'll do it over the page so you can see it a little bit more clearer. So you've got 1 equals 2a add b. And you've minus 9 equals minus 3a add b. If you subtract those, 1 minus minus becomes 1 plus, 2a plus, so a equals 2. Substitute that into any of the other equations to get your b. So I have now worked out my a. So come back up here again, worked out my a. So with a is 2 over this, and my b is minus 3 over this. So that's the coefficient. The next way is a substitution. So if you take this line where my fingers is at, and if I set x equals minus 1, and the reason I'm setting it to be minus 1 is because that bracket will disappear. So you always want to get rid of your brackets to disappear when you're trying your substitution method. So if I put minus 1 in, minus 1 take away 9 is minus 10. Minus 1 take away 3 is minus 5. I've got a straight away. Then to get rid of this bracket, choose x be 3 over 2. So put 3 over 2 into this side. And then over here, 3 over 2, that disappears. And 3 over 2 is 5 over 2. And then you can tidy it up to give you b. I tend to use that method. It's quite quick and get used to it. So let's see what we have in this one. Now I'm going to try the wee example out of the notes. So this is example 2, just in the CA notes. I need to factorise first so I can see what I'm breaking up into. So factorise it. So it's going to become something over this factor plus something over this factor. Multiply it by the whole bottom line. So you're left with 1 equals a x minus 1 plus b x add 2. As I usually use the substitution method, if I choose x to be 1, that bracket disappears. So I'm left with 1 equals 0, add 3b, so b is a third. To get this bracket to disappear, I'm going to choose x equals minus 2. So sub it in, 1 equals a times minus 3, so a is minus a third. So my expression can be written as a, which is minus a third, over this, plus b, which is a third, over this. Okay, so that's your basics of partial fractions. Now the next wee section here that we're going to look at is when you've got a repeated factor. So if you didn't know, it's part B, repeated factor. What a repeated factor is, you've got the same linear bottom, okay? And the way it splits up, it goes something over the factor plus something over the factor squared. It's a bit of a strange one, but we'll see what that means. So the wee example 3, just falling out of the C in notes. So you factorise the bottom as normal, and you'll see it's a repeated factor, so you got it in twice. So this splits up into something over x minus 2 plus something over x minus 2 squared. Now, times everything by x minus 2 squared. So the left-hand side just becomes the top line. If you times this by x minus 2, again I'll show you over at the side. So a, and at this line here, x minus 2 squared over x minus 2. You can see the way you're left with an x minus 2 on the top. And times that by x minus 2, it disappears. So I'm using my substitution way. So I choose x equals 2 to get rid of that bracket. So if x is 2, I get 5 equals b. Now, I've no other way of getting rid of another bracket. So I will now use the coefficient method. So what's my coefficients of x? I've got a 3 on this side, and I've got an a on that side. So a is 3. So I've now got my a, which is 3, and I've got my b, which is 5. We'll try another one of those. So if we look at number 4, it's already factorised for you, which is good. So it's a over the first plus b over the repeat plus c over on its own. I've got to multiply everything by this bottom line here. So we're just left with the top line. If I multiply this by this bottom line, I'm left with 2x add 1 and x add 3 on top. Multiply this by this bottom line, I'm left with an x add 3 on top. Multiply this by this bottom line, I'm left with 2x add 1 squared on top. Now, getting rid of these brackets. So, looking at the first one, if x is minus a half, that will disappear. So that's why I chose that as my first one. So 2 times minus a half squared adds 7. Minus a half in there is 0. Minus a half plus 3 is 2.5b. Minus a half in there disappears. So I've got my b straight off. Look for the next bracket to get rid of. Here. If x is minus 3, it disappears. So put minus 3 squared times 2 adds 7. Minus 3 in there disappears. Minus 3 in there disappears. Minus 3 in there gives you 2 times minus 3, which is minus 6, add 1, which is minus 5. Minus 5 squared is an ordinary 25. So C is 1. I've run out of brackets. So we'll now look at the coefficients. It doesn't matter if you look at the x or the x squared or the constants. I tend to start with the highest coefficient and work back, but it doesn't make any difference. The coefficient of x squared is a 2 on this side. Now, if you imagine multiplying this out, you get 2x squared times a. So the coefficient of x squared is 2a. There's no x squared here. On this one, if you multiply that out, you get 4x squared times c. So the coefficient of x squared is 4c. You already know what your c is from up there. So 2 equals 2a plus 4. Bring this across and bit of manipulation, and you get your a. So this expression here can be written as a, which is minus 1 over this, plus b, which is 3 over your squared, plus c, which is 1 over x plus 3. Okay, so far, in partial fractions, you're splitting them up. If you have a repeated root, you have that factor again squared. Okay. Now, improper fractions. This is the last bit we've got to get through. So I'll talk you through this. An improper fraction is when the top line, the highest power in the top, is equal to or higher than the denominator higher power. So what on earth does that mean, first of all? See, if I've got an x squared over x, that's improper because that one is bigger than that one. If you look down at example 6, see, I've got an x3 on top. Can you see the way that would be an x squared times an x? So that's an x3. They're equal. So that also means it's an improper fraction. So the top line highest power is equal to or higher than the denominator highest power. So x2 is bigger than x, so it's improper. x3 and x3, they're equal, so it's still improper. If you have improper, you must divide first. The highest power on the top must be lower than the highest power in the denominator. So you cannot go any further if you don't have that set up. Before I do this, we're going to look over the examples you've done. Look at the first one, example 1, x squared. It was okay. Look at the second one. You had no x squared. It was okay. Look at the third one, x squared was fine. Look at the fourth one, x squared over x is x cubed. So x squared over x cubed is fine. Over here, x squared over x, no good. So you must divide through. Now, so to divide through, I'll just do this on a page so you can see my division because it'll be quite hard to follow. So you take the top line and you divide it by the bottom. X into x squared goes x times. Now you times the divisor. This is the divisor by x. X times x plus 2x. You draw your line, you subtract. X squared minus x squared is gone. Minus 3, of no other numbers on its own, so minus 3, take away 2x. Now x into minus 2x goes minus 2 times. So now I take minus 2 and times it by the divisor. So I get minus 2x minus 4. Draw your line, subtract. Minus 3, add 4 is 1. And minus 2x, add 2x is gone. So that expression, x squared over 3 minus x add 2, can be written as, that's the number of times it goes in, and that's the remainder over the divisor. And that's exactly, oh, sorry, I was silly there. The remainder is a 1, obviously. 1 over the divisor. That's what I was doing there. You don't have to go any further because that's it finished. Now, example 6, I think this, we have one more after this. So let's have a look at this one. You cannot do anything because x3 in the top and x squared times x is x3 in the bottom. So you must divide. Before you divide this one, you must multiply out the bottom. So square out your first bracket. Square the first, double the product, square the last. Or just write x plus 1 times x plus 1 and times out the long way. Multiply out your double bracket and tidy it up. Now I'm going to do the division. So I'll just take you through this. So I'm taking the top line and I'm dividing it by the bottom line. X cubed into x goes once. So 1 times the divisor. Sometimes it's a good idea to move that plus 1 over at the side there so you have a bit of space. x3 minus x3 is gone. Nothing minus minus x3 is a positive x3. 1 minus minus is a positive. x3 does not go into x, so you're done. So the number of times it goes in is 1, and it is the remainder over the divisor. Okay, that's what I was doing here. Now, your divisor started life up here in brackets, so just put it back into brackets again. This 1 will just sit there. Go over to the side and do this bit in partial fractions. Note it's a repeated root, so it's a over this plus b over this squared plus c over this one. Multiply it by this bottom line, you should get this. I chose x3 minus 1 to sub in first. To get rid of that bracket and that bracket, leaving me 0 equals minus 3b, so b is 0. I then chose, if you look down at this line here, x equals 2, to get rid of this one and this one. If you choose x equals 2 and sub it in, you get c equals 1. And then I'm out of ideas, so I chose the coefficient of x squared. There's no x squared on this side. That multiplies out to give me ax squared, so the coefficient is an a. That multiplies out to give me cx squared, so the coefficient is c. You've worked out your c, put it in to work out your a. So basically, whenever there's a repeated root, you'll have your bracket and one type of coefficient. So you've got your a, b, c. So there's your a, b is 0, c is 1. Plug it into here. So this has become 1 plus this, which tidies up to give you that one. And the last one, part D. There's a lot of work on this. You probably have to split this up quite a wee bit. You might want to pause it here and then come back to it another day. But I'll just take you through this. So, partial fractions. Nothing fancy there. We're good to go. A over this plus B over this. Sort out your bottoms. Put x to be 2 and then x to be 1 to work out your a's and b's. So just run through this. Now, in this question here, you're asked to expand it out. So, let's get the question up here. So, it's expand up to the term of x3, stating the range of values for which the expression is valid. Right. So you've worked out your partial fractions to this stage and you should be okay. Rewrite that as minus 1 add x. Then bring the minus out. So it starts off with a 1. I just cover up. No, I'll just keep it like that. This one here, I've left it alone. So what I'm going to do now is I've written this one as 2 minus x to the minus 1, bringing that bracket up, minus, and I'm bringing that bracket up as a minus 1 to it. You can't use the binomial expression until you have a 1 plus. Now what I mean by the binomial expression, I'm using this equation that we've looked at, 1 plus nx plus n minus 1 over 2 factorial x squared, and n minus 1 n minus 2 over 3 factorial x cubed. I must have it starting off with a 1. So you remember how to do that. You divide everything by 2 and you take the 2 out with the power. This one here starts off with 1, so we're good to go. That's 1 over 2. 1 plus n x, so minus 1 times your x, which is minus x squared, plus n minus 1, 2 factorial, your x squared, plus n minus 1, n minus 2, 3 factorial, or x cubed, minus, now I'm doing this bracket, 1 plus nx plus n minus 1 over 2 factorial x squared, and so on. I'm tidying up the first bracket, taking away, tidying up the second bracket. Times out the first bracket and take away the second. Now you need your valid expressions. So if you go back up here, this one is valid for x over 2 less than 1, so x is less than 2. This one is valid for minus x less than 1, so x less than 1. So if you combine those both together, so if I show you a wee picture here, so 1 minus 1, one expression is valid for that. The other expression is valid for that. They're both valid between minus 1 and 1.